quick video here to talk about initial value and variation. In this example, we're shown several graphs and told that they illustrate different relationships between temperature and time. And for each graph, we're asked to state the initial value and the type of variation, which will either be direct or partial. So a few notes. First of all, the question mentions initial value. Just remember that initial value is another way of saying start value. So when we're asked to state the initial value, we're simply going to look for the starting value for the relationship. In this case, that would be the temperature when the time is 0. So we're looking for where the graph hits the vertical axis. And that'll always be true when you're stating an initial value. Just look for the point and state the value where the graph hits the vertical axis. The question also mentions variation, and we're asked to state the type of variation for each of the graphs and identify it as either direct variation or partial variation. So a very quick reminder of what direct and partial variation mean. A direct variation occurs when you have a linear relationship where one variable is simply a multiple of the other variable. So that is, it's a proportional relationship. So in this case, we'd have a direct variation if, say, the temperature value was always 5 times the time value. That would be a direct variation. A partial variation occurs when we have a linear relationship where one variable is not simply a multiple of the other variable. So how can we quickly identify the type of variation that we have for these 3 graphs? Well, it turns out all you need to know is the initial value or the starting value. Now, if you look at your graph and the starting value is 0, we will have a direct variation. That is, the only way you can have a linear relationship where one variable is simply a multiple of the other variable is if it starts at 0. And similarly, if the starting value is not 0, we cannot have that type of relationship. That means we have a partial variation. So as you can see, it's all about start value. If we look at the graph and the initial value is 0, we have a direct variation. If we look at the graph for our linear relationship and it starts at a number other than 0, we have a partial variation. Now let's look at our 3 graphs. For the first graph, what is the initial value? Well, there it is right there, 0 degrees Celsius. In other words, when the time is 0, the temperature is 0 degrees Celsius. So we can state our initial value is 0 degrees Celsius, and because the starting value is 0, we have a direct variation. On to the second graph. For this relationship, we can see that the initial value is 10 degrees Celsius. So the graph hits the vertical axis at 10, so we can state initial value is 10 degrees Celsius. And because the initial value is not 0 degrees Celsius, we have a partial variation. On to the final graph. This graph has a negative initial value. We can see it right there. The starting value is negative 15 degrees Celsius. Once again, since that value is not 0 degrees Celsius, this is a partial variation. And that's it.